everyone. In this video, we're gonna focus on evaluating definite integration. But first, let's define integration. Integration can be used to find areas, volumes, central points, and many useful things, but it is most often used to find the area under a function like this. So this is a definite integral. As you can see, it contains a lower limit a and an upper limit b, also known as the limits of integration. F of x is known as the integrand, dx is the variable of integration, and this is the symbol of antiderivative, which represents a limit of sums. In this image, the area bound by the graph of function and the x-axis and those a and b boundaries or limits is this. Basically, the definite integral of f from a to b with respect to x is equal to f of b minus f of a, where capital letter F is the antiderivative of lowercase f. If you encounter some equation like this is also the same as f of b minus f of a. The difference between definite and indefinite integral is that definite integral contains the limit of integration, which is the upper limit b and lower limit a, while indefinite integral doesn't have those. Another difference is that once we integrate the indefinite integral, it will give us a function and has the constant of integration, which is represented by letter c, while definite integral will give us a number or a specific value. Here's an example. Let's evaluate the indefinite integral of 2 with respect to x. The integral of 2 is 2x plus c. Since the derivative of 2x plus c is simply 2, because the derivative of 2x is 2 and the derivative of any constant is 0. So 2 plus 0 is 2. Therefore, the antiderivative of 2 is 2x plus c, and the derivative of 2x plus c is 2. On the other hand, for definite integral with an upper limit of 1 and lower limit of 0, the antiderivative of 2 is 2x. Then let's evaluate this from 0 to 1. It will be 2 times 1 minus 2 times 0. This represents the f of b and this is the f of a. Then simplify. 2 times 1 is 2 and 2 times 0 is 0. 2 minus 0 is 2. So the final answer of any definite integral is a number. Take note that definite integration, the final answers don't have the constant c. Let's start with this example. Evaluate the definite integral of x plus 1 from negative 2 to 2 with respect to x. In this example, we need to use the power rule. The power rule is the antiderivative of x raised to n is x raised to n plus 1 divided by n plus 1 plus c. Like I said before, in definite integral, we don't need the constant of integration. So the antiderivative of x plus 1 is x raised to 2 over 2 plus x. Let's see what would happen if we add c. So first, we need to calculate f of b. So we need to substitute x to 2 to the entire expression. So it's gonna be 2 raised to 2 over 2 plus c. In calculating f of a, we need to substitute the x to negative 2. So it's gonna be negative 2 raised to 2 over 2 plus negative 2 plus c. Let's simplify the entire expression. 2 raised to 2 is 4 divided by 2 is 2 plus 2 is 4 plus c. And on the other side, we have negative 2 raised to 2 is 4 divided by 2 times negative is negative 2, and negative 2 times negative is positive, and positive c times negative is negative c. The entire equation would be 4 plus c minus 2 plus 2 minus c. So positive c and negative c will be cancelled. That's why it's not needed. 4 minus 2 is 2, plus 2 is 4. So this is the final answer for our first example. Next example. In this example, let's evaluate the definite integral of 1 over x squared from 3 to infinity with respect to x. So the first thing that we must do is to rewrite this expression. So let's take that x variable and move it to the top before we integrate it. So now, we will have to evaluate the definite integral of x raised to negative 2 from 3 to infinity. So we just need to find the antiderivative of this expression using just the power rule. So it's gonna be x raised to negative 2 plus 1 over negative 2 plus 1, which will give us x raised to negative 1 over negative 1. Then, let's rewrite again the expression. So it's gonna be negative 1 over x. So now, we just need to calculate the f of b and f of a. F of b would be negative 1 over infinity, and f of a would be negative 1/3 times negative equals positive 1/3. 1 divided by infinity is 0. So 0 plus 1/3 is simply 1/3. Next, let's integrate this function. 8 over x raised to 3 from negative 3 to 4 dx. Just like in the previous example, the first thing that we must do is to rewrite this expression. Let's take that x variable and move it to the top before we integrate it. So we will have 8x raised to negative 3 dx. So now, let's find the antiderivative of this expression by also using the power rule. So 8x raised to negative 3 plus 1, so it's gonna be negative 2 over negative 2. Then, let's evaluate this from negative 3 to 4. But before we do that, let's simplify this expression first. 8 divided by negative 2 is negative 4. Then let's move back the x variable to the bottom. So it's gonna change to negative 4 over x squared. So now, we can plug in 4 and negative 3. So f of b would be negative 4 over 4 squared minus f of a, which is negative 4 over negative 3 squared. Then simplify. So it would be negative 1/4 plus 4 over 9. Then let's add these two fractions and we will get 7 over 36. And that's it. And for our last example, we have here the definite integral of 3e raised to 3x from negative infinity to 0 with respect to x. So in this particular problem, we're going to use the u substitution method. So the first step is to find the u, which is the 3x, then the du, which is 3 dx, then the dx, which would equal to du over 3. Then let's rewrite the expression in terms of u. Let's first move the constant to the front, so it would result to 3 integral of e raised to u from negative infinity to 0 du over 3. Let's also move 1/3 to the front, so the expression would be 3 over 3, which is also equal to 1 integral of e raised to u from negative infinity to 0 du. So we must know that the antiderivative of e raised to u is also e raised to u. So let's simplify. Since u is equal to 3x, the expression would be e raised to 3x, and then let's evaluate this expression from negative infinity to 0. So it would be e raised to 3 times 0 minus e raised to 3 times negative infinity. 3 times 0 is 0, and e raised to 0 is equal to 1, and 3 times negative infinity is negative infinity. And take note, any number other than 0 or 1 raised to negative infinity is 0. E raised to negative infinity is 0. So 1 minus 0 is 1.